Hello, my name is Christopher Archates. I'm an undergraduate student at Cal Poly Pomona, majoring in computer engineering. My entry to the 2022 Rising Star Student Competition is BroncoSat-1, Enabling Technologies for On-Orbit Artificial Intelligence Systems. BroncoSat-1 is a technology demonstration CubeSat mission designed to evaluate the technology readiness level, or TRL, of the NVIDIA Jetson line of single-board computers, SBCs, for use in space. What makes the NVIDIA Jetson SBC unique among other SBCs used in CubeSat missions in the past is the combination of an ARM-based CPU and a desktop-class GPU. Our team at Cal Poly Pomona first envisioned a platform which we called Quick, powered by NVIDIA Jetson SBCs to, among other things, accelerate artificial intelligence and machine learning algorithms. These algorithms would improve mission operations while in orbit, particularly for image processing for observational missions. But with a novel approach, we are developing methods to implement AI algorithms for attitude determination and control, characterizing the orbital environments and commanding the satellite to orient itself relative to the Earth's surface depending on the mission's needs. BroncoSat-1 will demonstrate the AI performance of the entry-level NVIDIA Jetson Nano computer via a series of benchmark tests using such algorithms. We would then report these results to our main flight computer, then transmit them through the Globalstar communication network. Here we see system block diagrams for the main flight computer on the left, which I will explore in the following slides, and the BroncoSat system as a whole on the right. CubeSats are a standard of small satellites created by Cal Poly Sloan and Stanford universities. They are typically compact systems, and for a mission like BroncoSat-1, electronics are a majority of the physical composition as well as the design, being critical to its operation and success. I had the privilege of serving as the lead electrical engineer on the project. My responsibilities encompass nearly every subsystem on the screen, designing, assembling, testing, and integrating the final satellite alongside a team of around 30 other students. First stop is the main flight computer based on the PyCubed architecture by Stanford University's Rex Lab. At its center is a microcontroller that can be programmed in either C or Python. We selected this board as a cheaper solution that has flight heritage or a history of being used on previous successful missions. But for our needs on BroncoSat-1, we required additional functionality. So we've added more components to the original PyCubed design, naming the new board the PolyCubed to honor Cal Poly Pomona's first ever space mission. These new subsystems include a real-time clock, thermocouple interfaces, a secondary inertial measurement unit, motor drivers, and I/O expansions to bolster our attitude determination and control capabilities, and to control our Globalstar radio communication systems. Here is a look at the fifth and final revision of the PolyCubed flight computer that will be used on BroncoSat-1 when it is in orbit. Although there are many more things I could still show off about my contributions to BroncoSat and of BroncoSat-1 itself, but can't under 5 minutes, I wanted to spotlight what literally tops off the project, and that is the top plate you see here. I designed for these external interfacing ports to program our flight computers and power the integrated satellite before launch, and taking inspiration from the golden records of these Voyager spacecrafts, I wanted to honor the students I worked with on the project, making use of the open real estate I had left so we can say there's something in space with our names on it. But I really wanted to honor everyone's hard work, tenacity, and perseverance throughout the project. We had to design, build, and deliver an entire satellite over the span of a couple months and through the COVID-19 pandemic. There were even points where we were willing to do so out of our own garages, showing how dedicated we were. On April 26, 2021, we delivered BroncoSat-1 to our launch provider almost 10 months to the day after first receiving the launch opportunity. BroncoSat-1 currently waits with our launch provider until we are able to launch sometime in 2022 to fulfill our mission.